a lot brighter, right?
Yeah.
Yeah. Well, at least it gives you more light out here as well.
We don't even need lights. We could just use the smart board.
That's what I said. It was getting so dark in here.
John will need his flashlight thing.
No. Aw.
Well, now you don't need it.
All right, so we do augmented matrices. That's what we just did. We just did an augmented matrix where you took the coefficients of your variables and you took the constant. The constant was the thing that it was equal to. That was an augmented one. Sometimes we do matrices that don't include those, which is when we do an REF. But when we do the other one and we put the constant out there, when you make an equation, 2x plus 2y equals 8, 2 and 2, those are your coefficients of your variables, 8 is called your constant. So whenever we set up our equations, you're going to have to set them up in the order of your variables. And they're going to be in alphabetical order, and the constant has to be on the right. They always have to line up. If you were missing one variable, you put a 0 for it. So say I gave you something and it said, 3x plus 2y plus 4z equals 1. Then I did 2x minus 3z equals 4. Okay, we have 3 variables. What's going to happen is you're going to have to line these up. You're going to have to put a 0 in for your y. You're going to have to put a 0 in for your z. They always have to be lined up. They have to be accounted for. So we're just going to put zeros in there as like a space holder. So that's where your zeros are coming from, if that didn't have one of those variables. So we just work rows times columns. This finds your dimension of your matrix. Okay, a column, think of a column like a column on a house, like a porch of a column. They go down like this. These are your columns, these are your rows. So you look at your columns, 3, you look at your rows. And that's how you're going to put your matrix in. But like I said, if you put it in backwards, say you put in 1 times 3, it's going to do this. And you're going to say, can't do that. Yes? Nope. Rows, there's 1 row, there's 3 columns.
Yeah, but don't you do row by column?
Oh, row by, did I do this backwards? Oh, I did it right over here, 1 by 3. Yes, thank you. This always confuses me until I put it in my matrix. So sorry about that. Row by columns. Okay, so what would the next one be?
We don't have this sheet.
You don't have this?
No.
I didn't know if we were supposed to be writing something.
Oh my goodness. I didn't hand it out.
It's alright, it feels like it's Monday.
I swear it feels like a Monday.
It does. I talked to you yesterday. I was like, wow, what did you do Saturday? And you're like, it's Wednesday.
No, I was like, no, I think it's Friday.
I was getting suggested everything.
So we put bunch of crazy.
I don't have it on Saturday.
I'm not in there.
Oh,
Bro, that's what woke me up. I heard
It was right over our farmhouse.
bro, I seen a lightning bolt.
what?
I was like, I had comes over my head.
It was like, it was down there and it woke me up a little early. Like you heard it was in one home and then it.
Okay, so figure out the dimension of the other 2 matrices. I'm going to hand 2 more of these. Thanks. Okay, everybody good? Okay. So what's the dimension of the second one?
4 by 2.
Where's my pen? Okay. 4 rows, 2 columns. How about this guy? What would this one be? 3 by 3. We call this one a perfect square. And when we do inverses, we're going to be looking for those perfect squares.
We're doing inverse matrix.
We do inverses, well, we do your inverse equations using the matrix. There's quite a lot this can do. We do determinants. I don't know if you ever heard of a determinant.
I feel like I don't know what it is.
You might, we can multiply them. You can actually do them in your calculator, but we're gonna add them and subtract them. We can't divide them because sometimes you get a 0, so it won't do a divide. But it'll do an add, multiply, subtract. But the multiply we actually have to do by hand.
It's on the ACT.
Is it really? Oh, so you know, if in your matrix you can just put matrix A, matrix B, and then you come back out, and all you do is this: matrix A times matrix B. That's it. That would do it. It's on the ACT for pre-calc, or oh, just in general. Oh, okay. Well, at least you can get there now. Okay. All right. So, an augmented matrix will include the variables and the constants. Now, again, there's something missing here, so you're going to have to fill this in. They have to be lined up, and it has to be in alphabetical order. So if you pulled out the coefficients, you'd get 1, -4, 3, and this is your constant, 5. Sometimes you're going to see me go like this, so that it's just separate. There's no way you separate your matrix, you just put the whole thing in. But so that you kind of realize that it's separate. If they wrote one of these in the opposite order, you would have to reorder it. So we just pull these out. Now what would the next line be? 0. Good. Good. Okay. So that's what we call an augmented. A coefficient only is only the variables. So in this case, we would just have this part. Okay, just that part. And sometimes, most of the time, we work with augmented ones. Sometimes we'll pull out their coefficients, but most of the time we work with augmented ones. And the next page, again, is just kind of designed so that you just get used to using your calculator with this. If you want to put this in your matrix, we can set this up and put this in your matrix. If you want to solve it by hand, you're more than welcome to, but we're going to use your matrix to do it. If you want to check it by hand, you can do that. So how would I pull out my coefficients and my constants? 1. Good. 0. Everybody get that 0? 2. Okay, so now you're going to put this in. What dimensions is it? How do I describe this in dimensions? 3 by 4. The nice part is if it's already in there, just write right over it. Just make sure one common mistake, and this is unfortunate because you don't see it, is sometimes you put the number in but you forget to hit enter, especially on that last one. And after you do all your calculations, usually you move on to something else, you have no way of seeing what you put in. So a good way to check this, if you're going to do this first, is to come back, put everything in, come out of your calculator, quit everything, and just put this in so that it prints out your matrix and you can check it. So you're just going to hit on the matrix A number and then it'll print out your matrix. Yes?
So, sorry, when do you know how to use REF and RREF?
I'm going to show you. Most of the time we're going to use RR, but there'll be one or two times when we do REF.
Okay, because that's only REF, right?
This is RR, yeah. This is RR. You can actually put your data into 2 different matrices and do both of them, but we're going to do RREF.
So is what you wrote up there the row epsilon form?
No, I didn't have you do that part. We're doing the RREF.
How do you get your answers from the matrix?
How do you get?
The answers from the matrix.
Okay, so where did you take your parts? Okay, so here. This is a binary system, so it's like X, Y, Z. X is on, X is 1. Y is on, Y is -1. Z is on, Z is 2. That's why they have to line up all the time and have this diagonal. You can almost see, well, let me write it on the board. So, can you read me yours, Rohan?
1, 0, 1, 0, 1, 0,
2. Okay, so again, this is your X, your Y, your Z, and this is what it's equal to. And when X is on, then X is equal to 1. When Y is on, then Y is equal to -1. When Z is on, Z is equal to 2. And these are your answers right here. That's how simple it is. These are your answers. So if you just took this column and went like this, there's your answers. X, Y, Z. You know how we hook them together? Your answers, we did them when we were doing the problems. This whole column right there is your set of answers. But they have to be in the same order. They have to be in the right order. That's why it's really important sometimes you're going to see they'll give you an equation and purposely they'll put it in a different order. But you're going to have to reorder this so that and you can keep them all in X, Z, Y order. Your answer will come out X, Z, Y. Whatever order you put them in is the order it comes out in. So what I usually say is just put it in alphabetical order. Make life the easiest. And basically, that's what I want you to get out of this today, is just figuring out like how to work with the matrix, being able to put it in your calculator, find the dimensions of it. Tomorrow we'll do some operations with it.
So are we just using RREF on our homework?
RREF, does it say on your homework what to use?
Well, number 41 says write it in row epsilon, which is just REF, isn't it?
REF.
Is it just REF when you don't have the constant?
Mm-hmm.
So you just take away what's on the equal sign?
Mm-hmm. Yep, just the first part. Actually, no. Actually, what happens is this. You want to do an REF one? It works a little bit differently. Keep this in your matrix. Let me put this in my matrix. Keep this in your matrix. Then you have to solve it yourself. So that's why I usually like to do this. Let me just put this in my matrix. We're doing REF on it. Put this whole thing in here. Do an REF, and we're going to have to back substitute in, which we can. It doesn't give you your answers. That's what I'm trying to say. Don't forget that second quit after you put your matrix in, or it won't let you do anything.
So are we putting that in REF?
Do REF. Leave this matrix and then just do an REF. So you get this. We have to solve this now. God bless you. Start here. It doesn't give it to you the same way. Start here. So Z is equal to 2. Start at the bottom and back substitute in. So now this equation says no x, God bless you, 1y plus 5z equals 9. Put your z in here. We have to back substitute. We have to solve it ourselves.
Oh.
This is the equation that it wants you to use. It reorders everything. It kind of makes its own set of equations for you. So then when you plug your z in here, you're going to get y plus 2 times 5 equals 9. And so y is going to be equal to 10 minus 1, negative 1. Then you're going to come to this equation. 1x minus 2.5y plus 2.5z equals 8.5. Now you're going to have to plug in your y and your z. You're going to back substitute.
Okay.
I asked you for REF on your homework?
You just
I
have
did.
to rewrite it.
Okay. If it says REF, build your matrix. REF is going to give you this. We don't really do a lot with REF. Because look, it's annoying.
The 1 negative 2.5.
Yep, this is to rewrite it in REF format. God bless you. You'll use that probably in calculus a little bit more. We don't really use it here as much because isn't it so much easier to use RREF and just go right to the answers if you're going to use a system?
Yeah.
There's some times we may use this, but it forces you to have to go back and solve it. But this way, if you do this one, it gives you the whole solution. But if your homework says RREF, just put that in, use RREF, and rewrite your equations. Back substitute. Okay. Always go to the last guy. That's the one with the 2 zeros here. Excuse me. If it doesn't have 2 zeros in it on the last one, then there's no solution. If it doesn't come out and say to you no solution, you kind of have to look at your matrix and say, well, I'm supposed to have a z equals something. No solution.